Welcome back to my Max Speed channel and as well as Math Electrical for you. Today we are going to learn about how to construct the root locus using the normal graph. So this is a basic introduction. We are going to see it in the class. Sketch the root locus for the unity feedback system which is given in the problem. First the transfer function we'll write it and then we'll make it equate to 0 in order to locate the poles and zeros from the given transfer function. So definitely we'll get the pole as s is equal to 0 and s is equal to minus 4. And solving this quadratic equation, we'll get minus 2 plus or minus j4. So that's why we have written s is equal to 0, s is equal to minus 4, minus 2 plus j4, minus 2 minus j4. So we'll name it as pole 1, pole 2, pole 3 and pole 4. That's why I named it. And always the poles will be marked by cross symbol and the zeros will be marked by encircling the circles. But since we don't have any zeros here, we'll leave it as it is. The roots, how to locate the root locus on the real axis, we should know it, and that will be able to calculate from the graph after in the second graph we'll see there. And the procedure is, I have given you some 1j, 2j, 3j, everything here. So this is the part of the graph which you are going to locate your poles and zeros in the graph now. So the first condition is s is equal to 0. So we'll have the cross symbol. Before that we'll try to take the scale of the graph, that is every 1 centimeter we'll take it as 0.5 unit. So we'll get 0.5 minus 1, 1.5, 2, 2.5, 3, 3.5 and 4 in the real axis. In the imaginary axis same we'll mark it as 1j, 2j, 3j and 4j in the same manner. Now we'll try to locate the poles in this graph. So one of the pole now marked as P1 is equal to 0. Second pole is marked as P2 is equal to minus 4. Third pole, that is P1 is equal to 0, is showing now. P2 is equal to minus 4 we have described now. And third pole is minus 2 plus J4. So from x-axis minus 2 and y-axis from J4. Same minus 2 and minus J4 will mark it in the third quadrant. So you'll get minus 2 and minus j4 now. So this is the procedure to locate your poles now. Third step, we are going to find out the before that how to locate the root locus on real axis. We'll see now. Take any one of the test point between these two poles from 0 to minus 4. I have taken a test point s is equal to minus 1.5 between 0 and minus 4. Count to the and one more test point will take it at s is equal to minus 4.5 will take it. Now we'll try to count to the right side of this value and we'll check how many poles we have. So we have only one pole. Always to the root locus on the real axis the count should be odd number. So it will be part of the root locus on the real axis. Now at the second test point we have taken s is equal to minus 4.5. Take that and count to the right side of this after 4.5. So we have two poles here, one is minus 4 and 0. So it is even number. So it will not be a part of root locus on the real axis. That's the reason we have like this. Now we are going to find out here asymptotes and the centroid. The angle of asymptotes is given by the formula 180 degree plus or minus 2q plus 1 and whole divided by n minus m, where n is the number of poles and m is the number of zeros. In this particular problem we have 4 poles and m zeros. So we'll have to vary the value of q is equal to 0, 1, 2 and then 3. That is n minus m minus 1. So 4 minus 1 it is 3. That's why you're varying the value of q is equal to 0, 1, 2 and 3. Now we'll take q is equal to 0. So 0 into anything is 0. 0 plus 1 is 1. So 180 by 4 is 45 degree. Like that we'll substitute for all the remaining angles, that is q value, and we'll obtain the corresponding angles for that. So we are getting 45, 135, 225 and 315 corresponding angle. Now we'll see how to find the centroid. The centroid formula is given by adding sum of all the poles minus adding sum of all the zeros divided by n minus m. So n minus m, once again it is 4 minus 0. But the varying of q value we can substitute by finding n minus m minus 1. so that we can come to know how to vary the value of Q now. By substituting all the values of your pole -2 -4 -2 plus J4 -2 minus J4 divided by 4. So we'll get the centroid as C is equal to -2 now. Now we'll see how to find the breakaway point and break-in point. Before that, we have to find the angle of asymptotes by using the formulas plus or minus. So we'll have all the terms with plus or minus for your angle to plot the graph now. Next, we are going to find out the breakaway and break-in point. So it is one of the most important concept, how to find the breakaway and break-in point. The breakaway point will always exist between two poles and the break-in point will always exist between two zeros. So without forgetting, kindly subscribe my channel for the further updation of your math electrical for you. So we'll proceed to the same manner. We'll see the transfer function, closed loop transfer function g of h divided by 1 plus g of h into h of s. So already we know the equation, how to find the characteristic equation. So g of h into h of s is given. On simplification we get like this. Multiplying on this equation we will get s power 4 plus 8s cube plus 36x square plus 80s plus k equal to 0. Find out what is k from this. So k is equal to minus s power 4 minus 8s cube minus 36x square minus 80s. So negative is common, we have taken that outside. On differentiating this dk by ds and then equating it to 0, you need to find the solution of your s value. Then we'll say which is your breakaway point and which is the break-in point. So whenever you want to find the breakaway point or break-in point, the condition is the value of k should be positive for every value of s. So in order to do that, we'll differentiate this k equation and then we'll equate it to 0. So s power 4 will become 4s cube, 24s square, 72s plus 80 is equal to 0. So the common on solving this cubic equation by using calculator will get -2 plus j 2.45 -2 minus j 2.45. We'll take first s is 1 is equal to -2 and we'll substitute in this k equation and we'll try to verify whether the answer is positive or negative. We'll take another s value, that is s2 is equal to -2 plus j 2.45 and the k is 100 now. Already every students know how to solve this equation and how to get the answer using the calculator. So with that procedure, now every value of k is positive for all these three values of s. But all the three values of s cannot be your breakaway point. So we have to locate in the graph and then we have to justify it. We'll see in the graph these conditions. Now we'll try to find how to find the angle of departure from the graph. We'll try to find it. Finding the crossing point of the imaginary axis. So whatever the characteristic equation we got it, we'll write that first. On substituting s is equal to j omega in the above equation, then equating a real part and imaginary part from this. Then we'll equate the real and imaginary separately. On simplifying that, we'll try to know what is the value of omega and what is the value of k here. So on equating the imaginary part, we are getting minus 8 omega cube plus 80 omega is equal to 0. So omega square is equal to 10. So omega is equal to 3.1 or 3.12 will get. We are round off and written as the value as 3.2. On equating the imaginary real part, omega power 4 minus 36 omega square plus k equal to 0. This k only will tell us what is the stability of the system for this transfer function. So on substituting omega is equal to omega square is equal to 10 in this equation, we'll get k is equal to 260. So this is the value for the stability of the control system. Now we'll see how to plot all your poles and zeros, how to mark your centroid, how to mark your asymptotes, every values. So first we'll take x-axis and y-axis in the normal graph. With every 1 centimeter, we are going to take for your 0.5 on the positive real axis and on the negative real axis. And y-axis every 1 centimeter will take the imaginary value as 1. So I have just shown you how to mark the scale in the graph. We have completed this now. Now first we'll write the transfer function, what we know it. Already we know how to locate your poles, what we have done it in previously. The same, I'll locate all the 4 poles first. Then we'll see what is P1, where is your P2, where is your P3, and where is your P4. So first P1 is 0, second P2 is -4, third P3 is this one, and fourth P4 is this one. So we'll see how to locate that. That P2 is -4 here now, and P3 is -2 minus J4, and P4 is -2 minus J4, and P1 centroid, already we know it is -2 now, that is marked here now, and centroid we are given it as SC is equal to -2 now. Already we know the angle of asymptosis is 45 degree, and third quadrant it is 225. That's why the straight vertical line is drawn now. And then second quadrant, second angle we know it is 135, and fourth one is 315. That's why these in the same with blue line we have shown you both the angles. So now for the understanding purpose, we'll show the first two arrow marks alone. Now it is 135 degree, and the first one is your 45 degree. So the angles will appear now 45 degree, and the second one is 135 degree. So with that we'll be able to know how to locate your graph now. Now next one, we are going to mark your breakaway point, and we are going to justify whether this is the breakaway point or not. So one of the breakaway point is S is equal to -2. So it is located between two poles, already we know it. And one more is -2 plus J 2.445. That will locate now. So this is the angle of the asymptotes of the line we have just shown here for understanding. Now with yellow line I have shown you what is the complex number breakaway point. We have got it -2 plus J 2.45, -2 minus J 2.45. So this is the centroid complex breakaway point. We have it exactly, since it is located between two poles now. So this is the procedure we have concluded, and this is the centroid and the breakaway point, we know it, that is -2 is also the centroid and as well as the breakaway point. One more important concept, we have not located the root locus on the real axis, that we'll see now. Now one blue line is coming here, and it is going to touch with 0 to -4. Since already in the first part of the slide I told you we have to count to the right side of this, and from 4.5 also we have to count to the right side. From 4.5 to the count right side we have even number, so it cannot be root locus on the real axis. For understanding purpose, I have shown you with one blue line here that you have to dark in the examination by using the graph. Now this is the called as the root locus on the real axis. So with this we have completed your graph. Now we have to write the scale for this, and in real axis we are going to take your sigma, and negative real axis we are going to take minus sigma, and y axis we are going to take it as plus j omega, and down we are going to take it as minus j omega. So this is the procedure to complete your graph now. Now remaining two procedures are there. With that we'll see how to write the scale for this. Every 1 centimeter we are going to take it as 0.5 units, and every y axis we are going to take 1 centimeter is equal to 1 unit. So with this the complete session of the graph is completed for the location of your root locus procedure. Now the same graph I will project it once again so that we can mark the remaining data from the original value what it. So once again I am projecting all the folds. Now in this case we are going to mark your angle of departure. For marking the angle of departure, we have to keep one of the pole as the reference, join all the other poles with this reference. So the arrow marks I am showing it to you to join all your poles now. Then we have to assume the angles for this, and the perpendicular bisector from pole 3 to 4 we have marked here. We are going to take this angle is your theta 1, and P2 we are going to take it as angle theta 3, and then P4 we are going to take the angle as theta 2. So now we'll see how to mark your -2 plus J4. -2 minus J4 is marked here. Now the same asymptotes line I am showing you once again. so that we need to mark the product of the length of the vectors, and we need to find all these values. So this is the centroid point, already we know it. Now this is the plus sigma axis, minus sigma, plus j omega and minus j omega marking of this. This theta 1 we are getting 117. I will explain you to the left corner end how we are getting 117. And theta 3 is 63 degree, and theta 2 is 92 degree, and theta 4, the unknown angle which you are going to find is minus 90 degree, and theta 2 is 90 degree here. When you see theta 1 we are getting 117. So this is the right angle triangle which you have it. So, and this is the entire semicircle we are going to use it. That is half of the semicircle we are going to use it. So theta 1 is 180 degree minus tan inverse of 4 by 2. That is this length, height we know it is 4. That is opposite side. And adjacent side is from 0 to 2. So that's why writing 4 by 2. So you'll get, and simplification will get 117. And theta 3 is once again from P2 to P3. This is also once again a right angle triangle. So we'll get P2 is equal to, this height is 4 and this breadth is 2. That is the adjacent side, and the opposite side we'll know from the right angle triangle. So we'll get 4 by 2, so we'll get 63 degree. And theta 2 is the perpendicular bisector, so we'll get plus 90 degree. Now we'll see how to find out this theta 4 or P3 or P4 we can write it. So P3 we are going to find out the angle, that is the angle of departure. So theta 4 is entire semicircle 180 minus theta 1 plus theta 2 plus theta 3, all the angles which you have calculated there. So with that we will able to get minus 90 degree. That's what you have done it. Now we need to write the scale here also in this graph. So please kindly, without forgetting, at the end of this session, please kindly subscribe to my channel for the future updation of this math electrical for you. So x-axis 1 centimeter is equal to 0.5 unit, y-axis 1 centimeter is equal to 1 unit. So thank you for attending this session with this nice presentation of the root locus construction. For any further clarification, you can just mail, or you can have the use my YouTube channel. You can share your doubts there also. We'll be helping you to assisting to solve your problems. Thank you.